Aloha, my name is Kalaiwaa and my presentation will be about using the makani, or wind, as a renewable source of energy. Renewable energy, as you know, is energy that is created naturally without using up the Earth's resources. I chose to use the makani, or limu lipu'upu'u in Waimanalo, as the energy, or mana, that will be powering my wind turbine. Energy exists in everything, and almost everything, like computers or sensors or even a phone, needs some type of energy to work. But finding a renewable energy or renewable resource that isn't taking advantage of the Earth's resources is very hard to find. Turning to renewable energy would fix that problem and help reverse the effects of global warming, but it makes up about 20% of the total world energy generation. Renewable energy should be sustainable, but in order for something to be sustainable, it must be limitless, and it also can help and hurt the environment at the same time. In the Hawaiian culture, mana is highly known for being a source of power or energy, and can also be known for being a divine power. Hawaiians treasured the aina, and in doing so, they were able to be sustainable for generations. Being able to just harness my own energy of my own creation would be a great accomplishment of mine and the main purpose of my project, which is to create something that is somewhat easy to make and something that will help me become more sustainable and hopefully influence others to make small changes as well. My project came about through a memory that my sister and I had when we were in elementary and used a wind turbine as a science fair project. The mana of Limu Lipu'upu'u, or the name of the rough sea breeze that blows hard through Waimanalo, will be the main source of power for my wind turbine. In figure 1, excuse me, in figure 1, this is a diagram of the Ko'olapoku Poko and their wind names. And this is Waimanalo right here. The first step was to figure out how I was going to make a wind turbine. So I looked up DIY wind turbines on the internet and was given a bunch of big turbines with materials that I didn't have on hand. So instead, I looked for smaller wind turbines, which is where I found on Thingiverse someone named David, who is a mechanical engineer in the UK, created a 3D printed wind turbine project. 3D printing is basically printing a three-dimensional model out of something made from STL files, also known as stereolithography, standard triangle language, or standard tessellation language, or a type of file format for 3D systems. The project includes the STL files for most of the parts of the turbine, as well as the screws, nuts, and other materials needed, and a manual for putting the turbine together. Figure 2, which is this, right here, is a picture from one of the pages of the manual that shows a visual of how my 3D printed wind turbine could possibly look in the end. Next was seeing if I was able to print the STL files or able to send somebody the STL files to 3D print, because at UPS it would have cost me $60 to $300 just to print all the parts, or maybe just one of the parts. So luckily, through Leanne De La Vega, I was able to meet this person named Caitlin. Her name is Caitlin, and she works in the 3D printing room at KCC, and she was a big help with printing the STL files. She was also kind enough to drop them off to me in Waimanalo, which was really convenient. I was able to start sanding the materials that she was able to print, because some parts didn't connect, like this one. These are the tail fins, and inside there was like extra 3D material, so I had to go in there with sandpaper and this sanding tool and these sanding tools to try and get rid of as much extra 3D substance as I could, so that these two parts can connect to these. And there's two of these because I broke one and she printed me extra. Thank you so much. So this is figure 3, and it's a picture of all the materials I was able to accumulate over 3 weeks. I was able to also buy most of the screws and the nuts but I wasn't able to find a 3D, not a 3D, this threaded rod that had to be a certain size to fit this on one end, the tail fin, and then the whole battery part on the other end. Between all of that, I was able to work on a plan for the Arduino. First, I wanted to make a regulator with the Arduino, which is this. This is the Arduino Uno that we were supplied. Well, also with a bunch of other wires and a bunch of sensors, which was really cool. But I wanted to make a regulator with the Arduino to help control the movement of the blades so they are facing the right direction of the wind and help store or control the energy being created. But for that, I would have needed a whole other Arduino, not even the Arduino Uno, just another Arduino, and a whole bunch of other sensors that I thought would take too much time to be shipped in. So I decided to go with something simpler, like a weather station. So I started hooking up the LCD screen, which is this right here, the LCD screen, and the DHT11 temperature and humidity sensor. And I got it to work, but it didn't work properly because I think it was broken. So it wasn't able to read successfully, as you can tell, and I wasn't able to print anything to the LCD screen. So that's in figure 4. I was able to put together the tail fin, which is this, and the battery component, which is this, but there's nothing in the battery component because the stepper motor, which is this, it couldn't actually fit in the battery compartment because it was too big. So I just decided to put together as much parts as I could and see what they look like. So I also was able to put together the blade compartment. So these are the blades, and then this is the compartment that holds the blade so it spins, but I wasn't able to find the right bearings to make them spin. In Hawaii, I have to order them online, so that would have took up time. And this stepper motor is basically consists of a metal core, then a space around the metal core, and then coils around that space, if that makes sense. So when the core turns, it conducts energy, and that energy I was hoping to store on the Arduino. But being that I couldn't find any of the bearings and whatnot, I was able to get my hands on a broken fan. So I'm hoping to connect the wires of the broken fan and its stepper motor to hopefully the Arduino to see if I can create energy instead of needing energy to create wind power, if that makes sense. I was also able to hook up this new temperature sensor, which I got working properly, as you can tell in the readings right here. And I also got it to print on the screen, but you can't see it that well. But for future references, I'm hoping to figure out a way to hook up the wires from the motor to the Arduino, and I want to learn more different ways on how I can transform the broken fan into a wind turbine, being that there isn't enough materials to be repurposed for the 3D printed wind turbine. And in conclusion, I learned many skills, especially improvising, because of a lot of the parts I had to use, I had to improvise in a way so that they can all fit together. Like I had to use a drill to make bigger holes for the screws because the screws didn't fit properly. Then I had to sand the materials so that they can actually fit together. I also had to take apart the fan. So I used a drill gun and screwdrivers and stuff. I also learned a lot of concepts. I learned more about coding, which was pretty cool because I just took a coding class last semester, and this just made me have a refresher, and it also allowed me to get more help with from the peer mentors and other students because they actually knew a lot more than I did. I also learned more about CADing because of 3D files. I can go in there and try to switch up a few things to maybe fit the stepper motor and make the holes bigger without deconstructing the whole files or ruining everything else. I also learned how to ask questions and be more confident in getting help where I need it. And then this is my references, not all of my references, just some of the references that I wanted you guys to see. I have more references on in another slide. And then I wanted to acknowledge everybody that helped me with this project, especially the peer mentors, because they're a big help in helping me figure out how to code and how to improvise where I needed, and just helped me a lot through this project. And I also wanted to thank the advisors for all the people they knew and allowed us to talk to further our curiosity and where we want to go in life, and just help in general, because I think without the advisors or the peer mentors, I wouldn't have been as productive as I hoped. But mahalo nui loa to everybody that helped me, especially Caitlin. Thank you for printing out my 3D parts. And I wanted to say mahalo to my auntie because I used up a lot of energy and electricity in trying to figure out how to use renewable energy to lessen my carbon footprint. Mahalo nui loa.